Turbomachinery Pelton Wheel Tutorial Question number 2. A Pelton wheel with two jets needs to produce power of 5,510 kilowatt and rotates at 329 rpm. Water was supplied with pipe system of length 1,000 meters from a tank located 350 meters from the nozzle. CV is equal to 0.97 and phi is equal to 0.46. Overall efficiency is 85% and Darcy coefficient is 0.024. Friction loss is 5% from gross head. Determine nozzle diameter, radius of Pelton wheel, and the diameter of delivery pipe. From this question, I hope you could draw a diagram like this from the question here. So for example, we have a tank here, and this tank will be connected by a pipe system like this, and then the water jet that comes from here will hit bucket from the Pelton wheel to produce power. So from the question, we know that the height of water level here is 350 meters, and then the pipe length here is 1,000 meters. We have CV here, 0.97, mean the losses between the nozzle here to the bucket here, and phi equals 0.46. Phi here is the speed ratio. In previous lesson, we know that the speed ratio is the ratio between U over V jet. The overall efficiency is 85% and the Darcy coefficient is 0.024. The Darcy coefficient here is the coefficient of major losses in pipe. And the friction loss is 5% from the gross head. So it means that 350 meters here is the gross head, and 5% from 350 meters here will converted to overcome the friction inside this pipe. First question, we need to calculate the nozzle diameter. From the question, we could calculate the effective head is 0.95 times the gross head. So the gross head is 350, so it becomes 332.5 meters as the effective head. Next, we could calculate the velocity of jet that hit the Pelton wheel here. We know when it's travel from nozzle to the bucket here, it has losses of energy here, and the coefficient of the losses of energy here is given by CV, coefficient of velocity, and it is equal to 0.97. So from the equation of CV, square root 2GH, so we substitute the value and we use the effective head here is 332.5 meters. We could get the velocity of jet is 78.35 meter per second. And this velocity is the velocity of water jet that hit bucket in Pelton wheel. From equation of overall efficiency here, we could calculate the flow rate. It's become Q equal power out over rho G overall efficiency and effective head. We substitute the value, we could get the flow rate. The total flow rate here is equal to 2 meter cube per second. Because we have two jets, the flow rate for one jet is equal to 2 divided by 2, we get 1 meter cube per second. Then we could calculate the diameter of nozzle by using this equation. This equation is come from Q is equal to AV. So that Q is actually the flow rate for one jet. So we have D square equal 4Q over pi V jet. We substitute the value of Q here with 1 meter cube per second because we are calculating only one jet's condition. So we could get the diameter of nozzle here is equal to 0.127 meter. Next, we are calculating the radius of Pelton wheel. The speed ratio, phi, is equal to u over vz. From the question, we know that the value of phi here is 0.46. So we substitute in this equation, we could calculate the value of u is equal to 36.04 meter per second. Then we could substitute into this equation. This equation is come from u is equal pi dn over 60. We rearrange that equation, it becomes d equal u60 over pi n. We substitute the value of u here and substitute the value of n here. We get the diameter of Pelton wheel is equal to 2.09 meter. Because the question wants the value of radius here, so we could say radius of Pelton wheel is 1.045 meters. Next, we are calculating the diameter of delivery pipe. From fluid mechanic 1, we know that the losses of pipe HF is equal to this equation, F L over D V square over 2G. And L here is the length of pipe and D here is the diameter of the delivery pipe. And V here is the velocity of water inside the pipe, not the velocity of water jet. And in the question, it was given that the losses in pipe is 5% from the gross heat. So 5% is 0.05 times 350, so it is equal to 17.5 meters. So we equate the value of this to the equation of major loss. Because we don't know what is the value of velocity inside the delivery pipe, we substitute the value of velocity here with the terms with flow rate. Because flow rate is constant, so it means that the total flow rate inside the Pelton wheel is equal to the flow rate inside the delivery pipe. That is the conservation of mass. So we substitute the value of V square here with 4Q over pi D square by the power of 2 here. And D here again is the diameter of the delivery pipe. So we rearrange this equation, we could have D by the power of 5 is equal to FL 16Q square over 2G pi square and HF. And it is equal to 0.453. And please take a precaution here. So this value is D by the power of 5. So we could calculate the value of diameter of the delivery pipe is equal to 0.85 meter.